All right, here we go. Verify this statement, shall we? Oops. Okay. So, verifications different from simplifications because we have an equal sign in the middle. That equal sign is telling us it's our job, our task, to turn these two terms into this, or to take this and make it look like that. That's our job, right? Make the left side look like the right side. And they don't look the same, okay? Now we have the toolbox to assist us in this. When we look across this, there's three things, right? And I'm not going back and forth between the toolbox anymore. You guys have been doing this for over a week now, okay? Do you see any fractions? Me neither. Do you see any squared terms? Me neither. Do you see any plus or minus signs? Yeah, I see one. Okay, now when you see that plus sign, look on either side of it. Anything I can factor out of that? Is that the difference of squares like we saw in the opener? No. Do they have anything in common? And if you're like, yeah, the x, then you have been out to lunch for the last week. No, I can't factor the x away from here. So no factoring, no fractions, no squared terms. That entire toolbox is out the window except for the option to write everything in terms of sine and cosine. Okay? So, we're going to do that. Tangent x is sine x over cosine x plus cosine x over sine x, that's cotangent. Now over here, secant x is 1 over cosine x, and cosecant is 1 over sine. So it's subtle, but hopefully you realize these are not being added, but these are. Right? There's a plus sign here, but not over here. That matters. Right? What can I do to quote unquote simplify? I just use the tool. What can I do to simplify? I can actually multiply these together, put them in one fraction, so I'm going to do that. I can't do anything here yet. But on the right side, to simplify that, I'm going to multiply the tops and the bottoms, and I'm going to get this. Okay? Now, again, we will say, our job is to make the left side look like the right side. That's what verify means. Work with one of these to get the other. Now, let me ask you this question. I'm your brain, I'm your conscience, okay? If I need this side to look like that side, this side has 2 fractions, and that side has just 1. How are they going to be the same? Big picture. The only way 2 fractions can look like 1 fraction is if I add them together. Philosophically, I hope that makes sense. Don't look at all the cosines and sines and anything yet. Just think, if I need to show that these two things are the same, then I need these 2 fractions to become 1. And if I want to create this matrimony where 2 become 1, what do I need in order to do that? In order to add these 2 fractions, I need a common denominator. How do we get that common denominator? We take our denominators and we multiply them. So I take sine x and I multiply that on the top and bottom over here. And at the same time, I take this cosine x and I multiply it times the top and the bottom over here. Now when I do that, what do I get? On the bottom, I get cosine x sine x. On the top, sine x times sine x is sine squared x. Right? Sine squared, cosine sine. I wrote it like cosine sine because multiplication is commutative. Doesn't matter how we write it, really. What about this second fraction? We get cosine squared x, and then down here, cosine x sine x. And then over here, we have this guy. So this is, I didn't make it obvious, but this is a tool from the toolbox. We have a tool in the toolbox that says combine fractions, find a common denominator and combine fractions. Or combine fractions by finding a common denominator. So that's what I'm going to do. I found a common denominator. That's one more thing I can do to help simplify this. So now, two fractions become one. To have and to hold, in sickness and in health. Till death do you part, as long as you both shall live. Do you sine squared x over cosine x sine x take cosine squared x over cosine x sine x to be your lawfully wedded blah blah blah, to have and to hold in sickness and in health? I do. Now two have become one. And you're all witnesses. But you're not invited to the reception because you can't have a reception because of COVID. That was a little humor there. I get the sense, Kaylee's smiling, although I can't really tell because she hasn't asked. Were you smiling? Because it's funny, right? It's a funny joke. Talking about getting married, but it's fractions, right? It's very funny, okay? For a Friday, that's pretty good. Now let's look at this. What's our job? Our job is to make this side look like that side. How close are we? We're not that far away because the denominators are the same. And then you look in the numerator. And then the side, right, are going off in your brain. If you've done enough of these, you should know what's coming next. What is sine squared x plus cosine squared x equal to? It is equal to 1. That's one of our Pythagorean identities. Okay? So what I can do is I can take this entire statement and I can say, I know that this is equal to 1. So I'm going to put a 1 in there. And now look. Ta-da! Check mark. Done. So it took a little bit of work to get here, right? But let's run through it one more time. No squared terms, no fractions, no factoring. So we write everything in terms of sine and cosine, and then we cleaned that up by multiplying those fractions. Then we looked at this and we said, I got two fractions here and one fraction there. If I want the two fractions to look like one fraction, I got to put them together. So we found a common denominator by multiplying denominators together. We put those two things together, and then we had to, and there's no really other way to say this, and I apologize because it kind of seems like a cop-out, but you just got to know that this is equal to 1. You've seen that. How many times have you looked at that Pythagorean identity? Many, many, many times. I didn't have to go into the margin, right, as I have in the past, because I didn't need to manipulate it. This is equal to 1, so I put a 1 in its place. Check mark. The two sides are the same. Mic drop. Ooh.